Today's video is all about layer height. What exactly does that mean? How do you change that in the slicer? And what are some gotchas? So if you've been resin 3D printing, well, you're brand new, or you've been doing it for 3 or 4 years like myself, you're definitely gonna wanna watch this one. For those who are new, the first thing I should probably show you is how to change it in the slicer itself. For that, I'm just gonna load up Lychee Slicer, and I'm gonna click on 3D printer up here in the top left-hand corner. From there, I've already selected the frozen Revo, which is what I use to print all these little bird guys. And then I've also already added the frozen hyperfine blue, which is the resin I used for this particular video. I think it's a great resin for this one. It's highly accurate and it shows up really, really well in the photos. And from here, you can see I've already got 4 different calibrations that I've done. However, if you're doing this for the first time, you're most likely gonna have the 50 UM one. So we're gonna start with that one and I'll show you how to change it. So all you need to do is just select the right one and click on the edit button. And here in the very top right under normal layers, you're gonna see it says layer thickness. Right now it's set to 50 UM. I can click this UM drop down and change it to millimeters if I want, which will say 0.05 millimeters. It's the same thing. But since I think saying 0.05 is kind of it's a lot to say, I'm just gonna switch it back to UM and I'm just gonna use that for the rest of the video. So from here, let's say I wanted to get really, really crazy and I wanted to print at 20 UM, which is something honestly I don't recommend, but let's just do it for the sake of this video. So what I do is I click over here and click on create a copy. This is gonna copy this entire resin profile. I'm gonna select my printer. I'm just gonna keep it on the Revo, hit copy. And now I'm looking at the copy. So from here, there's a couple things you need to change if you want to change the layer height. The big one, of course, being the layer height itself. So let's change this from 50. I'm just gonna say 20 because it's one I don't have right now, but again, I don't recommend using 20 UM. It's just way too thin. So the first thing you're gonna have to change is the exposure time. The reason for this being is a thinner layer is going to need less exposure time than a thicker layer. So if you're going up, you're gonna have to add more. If you're going down, you're gonna have to add less. It's like baking a cake. Thin layers of cake bake really quick. Really thick cakes take a long time to bake. It's the same thing in resin 3D printing. So I'm just gonna guess right here and say, let's probably put this at 1.2 just for now. The next thing we're gonna have to change is the wait before print. This is set at 2.5 seconds, which was good for 50 UM, but for 20 UM, it's probably not near enough. I'm gonna set this at 5 for now. I can always dial this back because that's gonna add a lot of print time. However, if I'm printing at 20 UM, I don't think I care about print time. I think I care about accuracy. So I'm gonna set this at 5. The next thing I'm gonna have to do is over the burn-in layers, kind of do the same thing. I was using 42 seconds on 50 because that's really thick and it needed that longer exposure time. But on 20, it's less than half the thickness, but we still wanna have enough there so it doesn't fail. So let's drop this down to, let's say 28. I'm just kind of making up numbers here. I really don't know until I start calibrating. Everything else I'm gonna keep the same. Nothing else you need to change if you're changing the layer height. Everything else is dialed in. And of course, if you're going up instead of down, the exposure time will go up, and you can probably have the wait before print actually go down on thicker layers instead of going up on thinner layers. But that's gonna take us to the next part of this video, which is, well, looking at how these settings actually affect the prints. And that brings us to by far the most complicated part of this video, which is properly calibrating if you change your layer height. Now, this is the part where if you're new or you've been 3D printing for 5 years, I guarantee you're gonna learn something new. And of course, if you are new, try to keep up. You may have to watch this video a few times before it finally clicks. Or you might have to join us on the Lychee Slicer Discord and reach out to me or the other moderators to kind of explain this in further detail and, well, to help you out. We're always there to help you out on the Lychee Slicer Discord, so come join us there today. But anyway, let's just dive into this photo and hope it all makes sense at the end here. So what I've got here is 30, 50, and 100 UM of these different boxes of calibration. All the pillars printed on all of them. And right here, we've got the exposure time. So at 30 UM, the exposure time was 1.6 seconds, all the way up to 2.8 for 100 millimeter, 2 seconds, and 2.2 for 50 UM. As you can see here, as you go up in layer height, you're gonna have to expose that resin for longer and longer and longer. Like trying to bake a thick cake or a thin cake. The thicker the cake is, the longer it's gonna take to bake. The thinner, the faster. Same thing with resin 3D printing. The LOD here stands for light off delay. Now this is really, really important. And this is kind of the reason why I have these pictures in the first place. If you try to go thinner, like thinner meaning like 30 UM or even lower than 30, which I don't recommend pretty much ever, you have to increase the light off delay or stuff just isn't gonna work out right. So I'm using 3 seconds for 30 UM and I went all the way down to 2 seconds for 100 and the ones down here. Let's zoom in here real quick because I can zoom in on these pictures pretty good. This is at 30 UM with, again, with 3 seconds light off delay. What we can see here is that the pixels are very uniform. The layer height is very uniform. I can see pretty much all the details and all the pillars. It's kind of fun to get these really close-up shots here. If I come over here to the overhang test, this is really kind of interesting. And of course, I really also want to look at the raft down here and how it's kind of held together. If I'm seeing some like weird layer thickness, because the raft is really hard to print. If there's going to be some problems with the layer thickness, it's going to be on the raft, which sometimes can cause the upper layers to have issues. Now, also, what I like here is that it's hard to tell in the photo, but I've got it right here. I can actually see through if I hold up to the light, I can see through all of the light. I think maybe the way the photo was taken is a little on an upward angle. It doesn't look like all the holes were showing, but all the holes were. Over here, I've got 3 out of it, and on the squares, I've got 4. The overhang test right here, there's a little bit of Z blooming, which means, we're kind of sagging down a little bit. It should be like a straight line. But all in all, it's actually pretty good. The thinner the layer height goes, the kind of harder this test gets in some ways. Let me explain that here in a second. But first, let's look at these ball right here. Now, this is just a ball, and it's printed. I think this is a really good test to show basically stepping. And stepping is caused by layer height. So right here, the stepping is actually quite minimal. This is very zoomed up. We can actually see the voxels being the XY resolution of the LCD itself. We want to see voxels. That's actually going to show us that we're getting a high level of accuracy. Now, I didn't run anti-aliasing on any of these tests. I didn't want to mess with these settings. So for everything you're going to see here today, anti-aliasing is turned off. It's not a part of this video at all. So let's go down and look at the 40 UM. So with 40 UM, that's where we're at. We're still at 3 seconds light delay, but we went from 1.6 to 2 seconds. An increase of 0.4 seconds was actually quite a lot. I was surprised at that jump. Generally, the jump isn't quite that high between each one. Let's look at these pillars right here. We can start to see more blocks. Here it almost looks like it kind of goes fuzzy, but it's really not going fuzzy. There's just not a lot of light to get onto. This is image stacked of like 200 images, and so is this one. So it's all technically in focus. It's hard to get light, so it looks like it's blurry. But in the 40 UM, we're starting to see more layers. We can definitely see it when we're zoomed in. And when we get to the overhang test, we're actually getting slightly worse results on the overhang test. If we zoom up here, it's a little more open. Things are closing up a little bit more. The boxes are not quite as straight. It's just overall, it's not looking quite as good. Part of this is because that extra exposure time, that 2 seconds. So the longer we leave the light on, the more resin it's going to cure a little bit deeper, sometimes a little bit too deep. Because to be honest, 3 seconds technically isn't enough for each of these layers to actually hit at exactly 0.04 millimeters. We've put some crazy equipment on our printers before, and what we've learned, if we want to print at true layer height, you're going to be putting in about 30 seconds every single layer light after light, which means you'll be adding 30 seconds. Your prints will take days. So it's like a bell curve. We start to see where the resin thickness becomes closest to the desired, and that's going to happen within those first seconds. And that's what boxes of calibration actually helps you determine. That's what this calibration part is designed to do. It helps you determine both of these values, not just one or the other. But anyway, looking at here, we can start to see things are getting a little bit more lines. We're starting to get a little bit of some weird stepping up here where it's getting a little thicker because of the thicker layers. We get down to 50 UM, which is the one that's probably the most popular. We're starting to see a lot more stepping on the top. So you can see here, between them, if we kind of zoom in, zoom out, we're definitely starting to see some of that iconic stepping here. We can see more layers, and something that's interesting was actually start to see some of this voxelization, these kind of circles on the side. They also start to kind of change their shape as well. That's just because sometimes the stepping can kind of eat into them. Now, if we go from the 40 UM to the 50 UM, probably the one that's most common, this is where we start to see some things make a little bit more sense again. And that's because I went from 2 seconds to 2.2, but the resin got thicker. That's what I was talking about. From 1.6 to 2, that's 0.4 seconds. And from here, I only went up to 0.2. I thought it was a little bit weird. I tested a few times, and that's just where this resin really kind of sat. And so I think on the 50 UM, we actually started doing better on the overhang test than on the 40. Again, I think that's just because the thickness went up, but the exposure time didn't go enough to match it. So we're getting slightly less Z blooming, and so it's looking a little bit better here. But if we look at the stepping, we're starting to see more of that traditional stepping we're used to seeing. Between the 40, if we kind of zoom out again, you got the 30, 40, 50. We can definitely see it more right here than on the other ones. And on the pillars, we're starting to see a lot more crazy shapes. It's getting kind of fun looking to look at these. There's a lot of light for the camera to pick up on, so we're starting to see just a lot more going on. You can definitely tell that the resolution is getting slightly worse. And just for the fun of it, I went all the way to 100 UM. Or 2.8 from 2.5. Again, not as much of a jump as I thought because we doubled the layer height. So there's definitely some Z blooming going on up here. We're over penetrating a little bit. By the time we hit 100 UM, the over penetration is kind of catching up, and the XY staying pretty good because this, like I said, this resin is actually pretty accurate. Now this pillar actually did print. Unfortunately, I broke it off. You can see the top here is connected, but here we can see some issues with 100 UM. And what we're seeing here, let me explain these shapes right here. The reason why you have these inverted triangle shapes right here is actually because there's technically not enough exposure to fully cure all the way through Z before we start to like really grossly over cure on XY. And so we're not getting great layer connection. Things are starting to get a little bit wonky, which is why we're getting that shape. This is a predicted shape we would get at 100 but we still got all the pillars and the boxes were still dimensionally accurate. So we're still good enough with this particular resin to print like this. But look at these shapes. This is just wild. And there's a lot for the camera to pick up on at this layer height, so it's actually pretty fun. We're not even printing circles anymore. We're printing like little mushroom caps. And yeah, look at this. Like we actually did really good on the overhang test. But again, that's because the Z blooming, it's having such a hard time penetrating as deep because there's so much resin. It's so thick that we're actually doing a much better job on overhang. And that's kind of maybe the first major lesson here is as you go down in layer height, it actually gets more and more difficult to consistently get to control Z blooming. So if you're printing with like clear resin or a maybe resin that's less accurate or like yellow, basically just resins that are more transparent, you're going to want to maybe increase the layer height. You may want to stick with 50 or 60 even if you're having a problem with that Z blooming, that your overhangs kind of over curing and just having issues with that one. As you can see here, moving up definitely helps out quite a bit. And if we look at the ball here, we can see definitely it's pretty fun. We're actually pretty consistent on the layer thickness, which does make sense. It's so thick the printer doesn't have to push down as hard and so much pressure when you get up this high. And then I even decreased the light off delay. So I'm here at 2 seconds, 2.5, 3, and 3. So I'm actually saving print time just because there's less layers, but also less light off delay. The next part of this video I think is kind of a fun one. And this is what happens if you change the layer height, but you don't properly calibrate the light off delay. I took a lot of photos of this one, but I only did it in 30 and 100 just to kind of prove the point. So let's look at these photos and see what they tell us. In this next paper, the ones on the left over here is where the light off delay is turned off, and the one on the right is where it's turned on. So the LOD off versus LOD on. So let's zoom in real quick and let's look at the pillars. And this is printed at 30 And the thing I really want to pay attention to is the rafts. As you can see here, the rafts where the light off delay is turned off are quite flaky, and we're getting some weird layer separation and stuff like that one. At 30, I think we're still compressed enough where it's still able to print okay, but most people are going to, again, probably printing at 40 or 50 And we'll show you the 100 in a second to kind of show how this can get a little bit worse as the layers get thicker and thicker. When it comes to the pillars themselves, there's not much of a difference here. These layers are quite squished together. And, these ones, what I'd be looking for is like, are we getting some banding? We see some banding here where you get like a thick layer here and there. What's going on there is you got layers that are too thick and then layers that are too thin. And that's just because the printer eventually is going to catch up and it's going to basically crush a layer out or delete a few layers. And that's what we're seeing a little bit of that here. If we go over to the one where we're using those 3 seconds light off delay, we're getting a much more consistency on the layer thickness. And of course the raft is looking much better, much more uniform. It looks like in these pictures, the raft on the right is thicker. That's just because the zoom level was a little bit off. It's kind of hard when I'm taking these photos to make sure everything's like perfectly the same. If we go down to the overhang test, this is where it really shows a lot. On this one, all the circles are pretty much filled in. We've got 2 circles, kind of, and then 3 and a fourth, and that fourth one barely counts. On this one, where we're using light off delay, all the circles are showing great. We got 3 and then 4. Yeah, it's quite a bit better. And again, on those rafts, a big difference. This one's even got some stuff peeling off of it because those overhangs are getting pretty thick. Again, the difference here is 3 seconds light off delay on or off. On these 2 orbs, we can definitely see some layer inconsistency issues here, where we're getting thick layers and thin layers. And that's where our layer thickness is not consistent at all. And so every once in a while, the print coming down is thicker than it expected. And it's going to push down into the release film, start deleting layers. And on the LOD on, we have a much better consistency. If we go over and look at the 100 so this is printed 100 and at first it's not looking too different. But as we kind of move over to the left, remember this is LOD off, we're starting to see some big issues right here. And this is where we're getting such inconsistent layers, is that there's actually not enough bonding happening, and we're getting layers kind of peeling apart when it's a little too thick for it. And so that's where we're starting to see these pillars just separate and really have a hard time. If we look at the raft as well, we're getting some deeper gouges in the raft where it's starting to kind of peel up a little bit. Luckily, it didn't peel on this one. Again, I think that's more to the resin. This resin is really easy to print and very high tensile strength. And if we look over at the one with light off delay, which I think on this one is what, 14? Yeah, a total of 14 minutes difference between light off delay on or off 100 on a tall print like this. For a short print like the boxes, probably closer to like 3 minutes difference total print time. Overall, just much better than we're getting over here with those issues. If we scroll down here, we're definitely getting some debanding here on this overhang. It's just overall not looking pretty good. Comparatively, these two things are very, very different prints. If we look at the balls, the orbs over here, not the blue balls, the blue orbs, it's less show than what you can tell with looking at something with more changes in it. I'd actually say these ones are showing that the LOD was rather insignificant change if we just looked at these ones, but that's why it's good to have multiple different shapes so we can determine if things are happening in one area and not another. But hopefully that's enough evidence to kind of prove to you why it's important to properly calibrate your resin if you're going to change the layer height either up or down. However, why would you want to change the layer thickness? Well, for one example, I've got this base right here that I printed that goes to my little lure right here. And this base, when it's sitting in the build plate, is rather tall and can take a long time. I don't really care about the quality, so on something like this, I might increase the layer height so that the print time is dramatically lower, and it also doesn't consume the life of my printer as fast. However, if I'm going to print like these little tiny miniatures right here, I might want to do something at a much lower layer height. It's going to take a lot longer, but I'm going to get a much higher quality. In fact, I printed all of these at 30 UM, 40, 50, and went all the way up to 100 UM, just so we can get some good images and some good data on does this print height change really make a difference on something like miniatures. I'll show the pictures of quality in just a second, but on print time, let's talk about these miniatures right here. The first one I got this written down, took 4 hours and 41 minutes to print. That's at 30 UM. For 40 UM, that took 3 hours and 32 minutes. For 50 UM, 2 hours and 45 minutes. And 100 UM, 1 hour and 22 minutes. So 1 hour and 22 minutes is the lowest, 4 hours and 40 minutes at the highest. That's a pretty big range of print time. So now let's look at some of the photos of some of these prints and see, does that time actually equate to a much higher quality that we can visually see with our eyeballs? And now we're to the part of the video of, can you even tell the difference between 30, 40, 50, and 100 UM? You can probably tell the difference between 100 and 50, but what about the other three? So for that one, I got some pretty zoomed in photos, which is going to make it really easy. It's kind of cheating at this point, but let's see even within these zoomed in photos if we can really tell the difference. So I've got 4 photos right here of this bird, and remember anti-aliasing is disabled for this video. Can you tell what layer height these are set to? I think it's probably somewhat easy to tell that the bottom one on this picture right here is at a lower layer height, or the layers are thicker than the other ones. But what about these two right here on the right? Can you tell that these ones are really different? Let me give you a hint. Let's zoom in on the beak right here, and you can tell me on the beak, you can say which one is better, the top one or the bottom one. Which one do you think is better looking? On this one right here, the bottom one or the top one? Sometimes it can be kind of hard to tell. What if I told you we can actually go slightly lower, down to 30 UM? Now I'm going to give you this away. Now we're at 30 UM. Is there a difference between 30 and 40? Maybe kind of hard to tell. What about the other side of this bird? 30, 40. We can definitely see there's more light on the 40. I'd say light's picking up more of those surface details. And so, yeah, for me, the 30 does look better, but this is a zoomed in photo. If I'm looking at the side of the face here where the light isn't like reflecting off it as much, it gets a little hard to tell between the two. If I go down to 50 UM, between 50 and 30, I'm starting to see a bigger difference but as I go up between each 10, it definitely gets smaller, and the smaller I go, I'm definitely getting diminishing returns. And again, we're cheating right here. We're like zoomed in pretty far on these things. But let's go up to 100 and 100. Yeah, I think for 100, we can tell the difference between 100 and 50. But as we get down to especially that 40 and 30, it definitely gets harder to tell. This is kind of a little bit more of a view where it's zoomed in a little bit less. We're still pretty zoomed in here, but it gets hard to tell the difference even from here. I mean, we can kind of get in a little bit on these two between 30 and 50, but I mean, not really. Like you can see on the beak a little bit more, getting more layer lines on the beak between the 40 and the 30. Between the 50 and 40, there's definitely still an improvement, but it's getting harder to see. And that 100 UM just looks silly. It's just there for fun. If we look at the other side again, I think this other side is harder to tell. This one almost looks blurry. It's not blurry. It looks blurry because there's not a lot for the camera to pick up on. It's just kind of a single color. And this is again without anti-aliasing, so we're starting to look pretty good. But on the 40, does it really look different? I mean, not really. They're pretty similar in almost every way. Yeah, and between 40 and 50, still the change here isn't great. I can see like a little bit of it here and there. In fact, if I look at the feet, it might be better. This foot hanging up here. But even then, between between the two. There's not a lot difference going on here. They're pretty similar. Of course, when you hit the 100 it looks terrible. But anyway, yeah, there's the difference between 30, 40, and 50 and 100 on this little bird. As we get towards the end of this video, I just want to do a quick recap of the visual quality versus the print time. So right here we can see the 100 took just under an hour and a half. The 30 took almost 5 hours. I think probably we can all agree that the 100 is probably not very feasible unless you're doing a base. However, whether you want to print at 30, 40, or 50 is really up to you, the user. I'm just here to present the data as well as I can and let you make the decision that's right for your resin and your Resin 3D printer. We'll put the links to download these photos if you want to look at them for yourself in the video description. While you're there, make sure to like and subscribe to the Lychee YouTube channel. It really does help out a lot for me to continue making content like this for you. And as always, thank you for watching and have a good day.